All right, now let's talk about the two types of correlation. Let's start with the correlation for when we have ordinal variables. Here's an example of that type of association research question. Is there a relationship between bank customers' education level and their evaluation of the bank tellers? In the bank's survey, both these variables were measured at the ordinal level of measurement. So as it says right there in the problem, both variables are ordinal. So we're wanting to see the association between these two variables. And for that, we actually have many options. This is the one that we're going to talk about in this class because it's the most versatile. And that's the Kendall's tau b. The null hypothesis in this situation would look something like this. And so this symbol you see right there is tau. And the null hypothesis is that there is no association between education and teller evaluation in the population. So this teller evaluation to be at the ordinal level could be that it's really bad, good, excellent, so it has categories to it that have a certain order to it to where one's better than the other. And then, okay, the null hypothesis or a alternative hypothesis is that there is an association between education and teller evaluation in the population. And just like all the other tests, we have assumptions and requirements. In this case, we only have two. First one is that both variables are measured at the ordinal level of measurement or higher. So really, this Kendall's tau b could also be used if we have interval or ratio variables. In our example's case, though, we have ordinal variables, and so that's why we're using Kendall's tau b. The second assumption and requirement is that the relationship between the two variables is monotonic. And we learned about that in the previous video. That means that there are no U-turns in the relationship between the two variables. So it should look something like these two. So what that tells you is that there's that versatility again, right? Kendall's tau b is not just for ordinal levels of measurement, it's also for interval and ratio, right? And then now for this other part, it doesn't even have to be a linear relationship. You could also use it for monotonic, nonlinear relationships. And when you run the Kendall's tau b, you'll get a number that has a range between -1 and +1. -1 would be a perfect negative relationship, and +1 would be a perfect positive relationship. And this Kendall's tau b is interpreted similarly to a Pearson correlation coefficient, which is probably what you're most familiar with from your other statistics courses, and we're going to go over that in a couple of minutes. First, let's get through these 2 points. And actually, this isn't even anything I'll go over because when it comes to effect size measures, it's not widely agreed upon. And so we're going to skip that part. And as I mentioned a couple minutes ago, there are other options for this type of analysis where we're working with two ordinal variables. Kendall's tau is one of the commonly used ones. Okay, so that's Kendall's tau b. Now let's move on to the correlation for interval and ratio variables. Both variables must be measured at either the interval or ratio level when we're going to use Pearson's correlation coefficient. And there could be three possibilities when dealing with those two kind of variables. It could be that both variables are interval, so interval, interval, or one could be interval, one could be ratio, and then one could both could be ratios. And just like Kendall's tau B, Pearson's correlation coefficient R has a range between -1 and +1. So same thing, -1 is a perfect negative relationship, and +1 would be a perfect positive relationship. Now, what about R when it equals 0? What does that mean? Well, it means that there is no relationship. So let's put that here. And one of the interpretations of the Pearson's correlation coefficient would be the strength of this association, right? Because remember, we have an association type research question, and so we want to know the strength of that. And when we plot the two variables, we're going to get an idea of that strength. So here is that graph again where we look at years of experience in sales. And when we have something like this to where we could draw a straight line, it's going to be to where these dots are pretty close to that straight line. And when that happens, we call this a stronger relationship. Or at least it'll be something stronger than what this one is. So we'll just say this one is weaker. Yeah, we can draw a straight line through this one also, but the dots are going to be farther away from the line. And when that happens, it's going to be a weaker relationship. So if I was going to guess, if I were going to guess, this one, let's say probably a 0.9, something like that, R, it's going to be positive because it's going up. And then this one, I would say it's probably between 0.6 and 0.7. So from that coefficient, that Pearson's correlation coefficient, we can determine or have an idea, have a way to express the strength of the association. All right, last thing in this video would be the assumptions and requirements for using the Pearson correlation coefficient. And for the first one, we already talked about that. The variables have to be interval or ratio, and it could be three different ways of pairing that, right? Interval and interval, interval and ratio, or both could be ratio. And then number two, we're kind of used to this idea of looking for outliers, and that would be the same case here. There are no influential outliers in either variable. And then number three, the analysis results in residuals are normally distributed. This is most likely to happen when neither variable is severely skewed. So we've already kind of covered this also in other tests, just looking at the skewness and going from there. And there's this word residuals, which I'm not going to go over in this video. We'll do that when we get into other stuff, let's just say that. But for now, just take it by faith that when this is one of the requirements and that we can move forward if this is met. Let's just leave it at that for now. And then the last one is that the relationship between the two variables, it does have to be linear. All right, in the next video, let's do an example.